Okay then, well, slag minerals from Letmathe. First, just a short introduction on the location, and it's a historic locality in Germany, which was active, since the 1500s or something, and it originally was a quarry area a mine area for limestone, lead, and zinc, and they built a smelter, which was active from 1866 to 1925. So it's just about 100 years inactive now. But the dams were still accessible until 1986. Nowadays it's a nature reserve. And I've never been there because this 1986 was about 2 years before that I started to collect. So I've not found anything myself, but the Mindat lists 176 species from there, but in the book from Wagner and Dönel and out from 2020, they list 168. So I'm not sure which is right. And in any case, it's only slag minerals, and they all have lots of bizarre forms. You find things there that are, let's say, quite indigenous to the location. Almost everything is analyzed. That the reason is because a large part of my collection comes from the co-author of the book. There's Bernd Dönel. He lives about 200 kilometers from here. I was in his house about 2 years ago, and I took over, let's say, the largest part of his collection, and all the specimens that are listed and photographed in the book. And I got the book from Uli Wagner, the other author, and the people who attend the BMS symposium every year know him because he's a regular visitor there. And he gave me the book in 2022 during the BMS symposium. Now, another part from my own collection from there comes from an internet sale in 2017. Eventually you'll see that I have over 50 species in 76 specimens. And the first one is acantite. It's a silver sulfide, as you know. You see a very rich specimen, and the best way to recognize it as such are the little tree. Can you follow the mouse? Are the little tree-like growth here, up here. These are typical for acantite, and this is quite a rich sample of it. Another one, the next one is alum K or Kali alum. I don't exactly know how to pronounce that in English, but we here call it Kali alum. It is from the metric system, isometric system, as you can see, but that's normally is very impossible to observe. And visual recognition of the stuff is equally impossible. It's very abundant in Letmathe. It forms a lot of, let's say, background and matrix, but it looks more like an amorph mass than as isometric crystals. This one at least is analyzed as such, but I may have another one which is not directly analyzed, but I found that just a few weeks ago in my own basement. The only thing that I can make of it is this LMK, but that's purely my own observation. So I probably should let it be analyzed. But this is the only thing that I can make from this building, you can say. Then acarganite is an iron oxide and can easily be refused with some other iron oxides with goethite. For instance, iron oxides are very sorry, are very abundant at the location. When I say is, I always mean was. So they were very abundant at location, iron oxides. And this is, let's say, an analyzed specimen of acarganite. Yeah, it contains nickel also. This is a double terminated anglesite. And that's at least in a habit that is quite common and recognizable to most of us. It's sharply pointed, colorless, transparent, translucent, so it's hard to miss. But there are, let's say, more complex forms also. This is also anglesite, and the little black dots are franklinite crystals. They are ingrown, and they are always, say, irregular. Franklinites are almost always irregular. But these are ingrown in the anglesites here. Then we have aragonite, that's not all too common here. And besides that, it's not very pretty, but well, just to be inclusive, I took this photo to show you. This is let's say, the typical form of aragonite, as it occurs in many places, and here also. And this is a combination. Brown youngite is zinc sulfate, and that are the white orthorhombic platelets that you see here in this picture. And in Letmathe, they are often accompanied by light blue trigonal platelets of the zinc, copper sulfate, NaMu white. NaMu white are the light blue platelets here. So this is a combination which often occurred in Letmathe. White brown youngite, and light blue NaMu white. Then the ugliest of all, this is brown millerite. It's also an oxide that you would never have, I would never have recognized it as such. And without thorough analysis, I don't think that anybody could imagine what it is. But yeah, this is the ugliest of all, I think. Which just to be inclusive again. And now for the bizarre things. These are now it's getting interesting. It's been established already a long time ago that this blue-gray stuff is cassiterite, and the formula shows that cassiterite is a simple tin oxide, but it can take many forms. And the drawing that you see is the simplest of all. There are a lot more drawing varieties. The yellow stuff is valamophite, and that makes sense because valamophite is a secondary tin oxide, and here well, they are all almost always together. I'll show you a number of these bizarre cassiterite beauties with just a little or no comment, just to have a look at them, and you see how bizarre they are. Here's the first and the second. As you see, the gray points, you could say, are cassiterite, and they are covered in white stuff. That's or hydrozincite, and that's more likely, this is zinc aluminite. And zinc aluminite I will show you later. I'm not sure about which of the two it is in this case. But you know, it's normally more likely that it's zinc aluminite. And this one, and you see, is now these are great samples. And this one, I don't even know how this growth can be possible. It's somewhere in the air. I decided to go up and then go back to the left. And also here, the yellow stuff is valamorphite. But how this thing grows, that's an enigma to me. This is even more complicated. One long rod with many small things on it. And this rod is about 2 millimeters, which is very long. And then we have some sort of, a different form. The yellow stuff down here is zincite. That comes later in this overview, but this is zincite. And then we have sort of sort of a road sign maybe. This is just as weird as they all are. And the last one from these bizarre things, Merry Christmas. And there are a lot more of these on my website. But well, they are. I think they are beautiful and bizarre, so they make nice photos, I think. Then we go to Klarite. Klarite is a bit unexpected to me because the color differs from the Klarites as I know them from the Clara mine in Germany. This is much more pale blue, while the Klarite from the Clara mine is much more brighter blue. This is pale, but it's analyzed to be Klarite. Copperite is simple stuff, copper sulfide, very common also here. But for the trained eye, it's quite clear and you can recognize it visually due to its characteristic blue-black color. It's always a bit black, but it shines blue. Yeah, there's a blue shine on it. So. This one I would never have guessed, and I don't think that many people would have guessed what this is. You should think it's auricalcite or deviline or maybe serpyrite, but it's not. It's quartz tibite 1M, and so this is what you can call a nice surprise because it's the only one I have in my entire collection, the only one I've ever seen. It's not too rare, but well, for me, it's it was a new find. Cuprite needs no further introduction, of course. Here it was not very abundant, so this is a good find, and you see that there's this myriad of crystals, all in the typical cubic habit. This is diopside. Diopside, as you know, is clinopyroxene. It can take several color variations. Mostly they are green, but here and sometimes, and here they are yellow as this one. And well, I think it would be quite difficult to visually recognize it, but as long as it's analyzed, I think I can trust the label. This was also a surprise to me, at least. I know dippingite from many places as spherical white spheres, white half spheres actually, and I haven't seen before in a habit like this. So this hairy variation is for me at least is an exception. And at last I could not find the crystal drawing stuff. But normally, and mostly in Italy, I found many dippingites These white half spheres. Ileite can hardly be confused with something else. The color is decisive. It's so characteristic that you always recognize it easily. And that's the only characteristic that you need to recognize this as ileite. And ileite is, let's say, quite common in slags in general. And here it's relatively abundant. Enstatite, this one is, as you know, is orthopyroxene. And worldwide, and for instance, in the Eifel here in Germany, it's very abundant, but here it seems to be much rarer because this is the only one I've ever seen from there. In all the stuff that I have, I still have, let's say, 8 or 10 fruit boxes full of raw material from there, which I always also got from Berndeuvel. It's not even clean, so I still have to work for over a year before I can make something more of it. Originally he gave me 22 boxes, but a lot of them I just gave away because I just have the time and the patience also to go to all these. But I still have a few. Then ettringite, it's quite easy to mix this one up with aragonite or some zeolite maybe, but actually it's ettringite. And ettringite is hexagonal, and often indeed to flat end faces, but often also it's pointy, and this is not too clear. Well, in the Eifel you have mostly these six-sided with flat end faces. So those are, let's say, relatively easy, but this one is, it's quite more difficult. This without analysis, it would be, let's say, a difficult job. Firelight is the iron-dominant end member of the Firelight forsterite series, and it's better known as olivine. Firelight is almost always brownish and opaque, where forsterite, that's the magnesium end member, is transparent and mostly colorless. So they are easy to keep apart, but there are varieties of olivine. The end members of the olivine series. Ferrostronzite is an iron phosphate. Phosphates are well represented here. All stronzites are colored pale beige, are as such quite easy to recognize. But there can be sometimes a confusion with the next one, which is confirmed ferrisimplesite. As an iron arsenate, you know the simplicite is grayish green. It's also an arsenate, but because of the iron here, it's always golden brown, and this is called ferrisimplesite. And you find very nice arrays, somewhat flattened small crystals like this one, but also in spherical arrays pointy. This is also ferrisimplesite. And these are very small. The crystal group is only 3/10 of a millimeter. So that you have a lot of trouble finding these things. Because the matrix almost always is very complicated. Contains lots of different minerals, and finding the best things in between. It takes some time and some study. Ferrocylite is also an orthopyroxene. It's closely related to enstatite because enstatite is only ferrocylite minus Fe. So andesite is Mg Su2O6. Ferrocellite is Fe2 plus added. And in the general practice, they are very difficult to keep apart. So normally, often they are just called ferrocellite andesite series. These are garnite crystals. Garnite is the zinc-bearing member of the spinel group, mostly with a blue to black blue color. But without proper analysis, you can never tell. So if it's not fully analyzed, you can only say spinel group. But this is analyzed garnite, and that's the zinc variety. This is the biggest surprise and enigma to me of all. It is analyzed, the crystal drawing is reasonably okay, and there is nothing else in the specimen to confuse it with. But so I have no choice than believe that this is truly goslarite. But I couldn't find no single photo of any goslarite all over the internet which is crystallized like this. Everything is dull and opaque, and so I keep my doubts, but it is analyzed, so it should be correct. But if it's correct, then this is, of course, well, a very rare and a great specimen of this stuff. But maybe I should let it, let's say, reanalyzed again, because this is not really not normal for this species. Gypsum is no fun because this place is flooded with gypsum. On the outside, it's always neatly crystallized, so you always find nice specimens of gypsum, but it's very abundant here. These things are not at all recognizable by the crystal shape. But all these beige brownish bulges are hidalgowite, and they're easy to overlook because you might think it's just some outgrowth instead of a mineral, but it's actually a mineral. It's a sulfate, and it's called hidalgowite. And all these bulbs there are a lot of them, so I think they have a lot of exchange material called hidalgowite. I would have never have guessed this one. I don't recognize it, but according to the analysis, this octopus is made of hydrocalamite. I already knew the species from the Eifel, and there it forms these ultra-thin platelets and colorless platelets, as you see in the drawing here. But apparently it can also do many odd things like this one. But I would never have guessed. Chitinosites are best known as platy crystals with more or less straight top faces. But once in a while, they can also show sharper end faces like this one. The color is characteristic, and the photo is not my best one, I see, because it's not sharp enough. But at least it is chitinosite, and it mostly overcoats other material. I'll show you that later. But this is, say, an individual group of chitinosite crystals. This one is nearly impossible to recognize visually, but this turned out to be lanakite. And lanakite is always pointy, always, let's say, spherically arranged. But the density of this one is quite unusual. So I think this is quite a fine example of this lead sulfate. Marcasite was not very abundant, clearly secondary growth. It surely looks as this here, this one is blue on some industrial object. And it's one of the very few that shows, let's say, identifiable crystals. But I think this is growing on some pipe or something. Then we have massicotite or massicot, also in the name. It almost always occurs together with reddish lithargite, that you can see at the bottom here. As you can see at the bottom of the picture, this is lithargite, I would say. And it makes a lot of sense because both are simple lead oxides. And I know that massicotite is orthogonal and lithargite is tetragonal. But I actually don't know why the one is green and the other is red. Well, I just don't know why that is. One of the finest in Letmathe is meta-switzerite, and it's one of the typical Genna species in smelter. And first of all, if you come across specimens that are labeled switzerite, then that is always wrong, because switzerite cannot exist in air. In contact with air, it immediately decays to meta-switzerite. It's very thin, it comes in different shapes as the photos, as the drawing shows. The most recognizable is this one here in the middle. That's the upper crystal. And this is a bit more flat, but this is totally exactly as the crystal shape should be. And it's always colorless to golden brown. Here's another one. And this is very fine and very fragile stuff. And you see also that this is very thin crystals upon each other. And then I have a third one, which is completely different. Is this? I had this one came from the old collection that I bought over the internet in 2017. And I first thought it was something else, but because I wasn't sure, I have let it be analyzed by Joy de Soo in Germany, and he confirms, or he tells me that this is meta-switzerite also. But yeah, I would say this is sunny side up, and this is very unusual appearance, I think. But it should be also meta-switzerite. Then vivianite comes later. This is meta-vivianite. That's the hydrated meta version. And the crystal shape is typically as vivianite normally is. And this is meta because this is not transparent anymore. This is completely opaque and beige instead of blue. And this is vivianite, which is decayed to meta-vivianite. Copper is abundant in all different shapes and sizes as we know them from everywhere. This is the bladed form. This is the curly form that is found in many different slags also. I found a lot of those in Greece, slags also. So this is copper. And we have curled native silver. This is a big one because it's 10 millimeters. And this show is also typical for there. But silver content is quite high. Olivenite speaks for itself, I guess. But how abundant it may be in some places, as in Germany, in Clara, for instance. Here it's very rare. I just have one. And the only reason why I know that this is olivenite, because that's the color, but also this end here is exactly that one there. So this is without any doubt olivenite. I have not analyzed this one because it also came out of the older internet collection. But this, without any doubt, it is alunite. Then something that you don't see every day, odoniazite, it's zinc and timonite. And you understand that this stuff can easily be confused with a lot of other things. So without analysis, it's unidentifiable. What puzzles me further is the crystal drawing, because that doesn't really match the rods that you see here. But okay, there are a few different shapes, all with some thickness around the waist. But all photos that I can find online show longer, slim rods like these. So I'm not sure, but at least it's analyzed. So it is on your side, but the crystal drawing is a bit confusing. Ozarizawa is named after a mine in Japan, Ozarizawa. Ozarizawa is a member of the alunite supergroup, therefore impossible to identify without full analysis. Nevertheless, this green bulky stuff here is always this Ozarizawaite. Ozarizawaite. Yeah. Now the most fascinating, in my view, the most fascinating of all. This species used to be called bindheimite, but the name is obsolete by now. So and that's probably more familiar to most of us. But this is called now oxyplumboromite, and the basic structure is octahedral. You can see that here. This is one single crystal of 0.2 millimeters. But this is the let's say this is the basic, and now come the weird things. I show you a few, like this one. This so it's sort of wet stuff. But these tree-like structures are quite abundant, and this is a much larger tree, and I suspect that this is grown on, for instance, cassiterite. That's one of the possibilities. And the most beautiful of all that I have is this one. And it's the best one, without any doubt. You see the tiny individual octahedrons here that form all these branches, and they're completely straight in a fantastic color. This is really the best one I have. Oxyplumboromite. And then they can be white too, in which case they are covered once again by hydrozincite or zinc aluminite. And this is also called oxyplumboromite because the octahedral structure is still visible here also. And then this is pyrite, simple, plain and simple. Balls like these are too common. And out of many, I picked the drawing that comes closest to these balls. But it's in any case, it's pyrite. Then a neat one, I think. Robertsite is a phosphate that can easily be overlooked when the color is less obvious than this one. They can easily be confused with a number of iron minerals, but and this one may count as an exceptional specimen just because of this shiny red color. The blue platy crystal is vivianite. It's also a phosphate. We'll see a few of those shortly, but they're all calcium. This is calcium manganese phosphate, one of the many phosphates that were found in Letmathe. This is really a good specimen of this robertsite. Sapphirite, always in a soft blue color, was very abundant at the location, and almost always in radiated sprays like this one. Sometimes it occurred all by itself, but mostly it sits on zincite needles. together with zinc aluminite, together with ktenosite, and you can see that in the next picture. This is grown, always soft blue color. It's grown on cassiterite needles, or maybe zincite needles, that's possible too. But it's a secondary growth on something. Then we have sulfurite also, but then on zincite rods. In this case, as often together with zinc aluminite in the form of tiny white six-sided platelets. But they are so small that you only can see them on the say large magnification. But these rods are zincite, and on them are sulfurite and zinc aluminite. Then we have something I'd never heard of before. That was stanskiite. Stanskiite. It's a triclinic, and I didn't find the drawing, but it's a triclinic green arsenate that I had never heard of before. You can imagine that you can easily confuse this with a lot of other things. Brochantite, malachite, just name them. But this is analyzed to be stanskiite, and it's quite rare because it's described from only 6 localities worldwide. And Tsumeb in Namibia is the type locality. But I said I didn't find any crystal drawing on the internet. Stanskiite. These are irregularly formed and therefore not immediately clear, but this is sulfur. And the color is typical. Sulfur is always, or very often, irregularly formed, so that's not a surprise. But recognizing it, okay, not too complicated. Another one which I never had heard of before, sundeosite. That's lead sulfate, PbSO4. Impossible to visually identify. It's very rare, only 3 locations worldwide. The type locality is Langbon in Sweden, and it's named after a Swedish mineralogist, Sundeos. And also here I didn't find any crystal drawings, and I never heard of it before, so it was new to me also. You saw already very simplified. This is, let's say, normal simplified. And it also contains iron, but in another composition, I think. It's an arsenic, but it's not very widespread here. And besides that, they are very, very small, so detection is easily overlooked. But the green color tells me that it's simplified. I already told you something about valamophite. No drawing available, but no doubt valamophite always grows as a secondary accessory mineral on the cassiterite needles. Here's another one, you can see those. So you can see the needles underneath, and this is without any doubt valamophite. Then we get vivianite. In a lot of places, vivianite is black and difficult to notice on an often dark underground or background. But there's a lot of them. But here, a lot of them are blue-gray and well developed. And let's say that this is the basic form, and this is just one or actually 2 crystals, but they have the basic shape as they are written in the book. But they come in a variety of habits as plates. Now, this is not the best photo, but these are combinations of vivianite crystals. And the same goes for this one. This is one of the best I have, I think. And these are in a certain area of the quarry, these things were very abundant. So I have a good number of them. I think 20 or 30 or so. And these all in these combined forms. And you see my sprays also with this slightly different end faces. This is just one drawing. But there are more than one. These are end faces are a little bit different. And then we get willemite. They are definitely not so pretty as the famous willemites that you see that come from Portugal. At least these are blue, and pure willemites are colorless, but sometimes they are blue. The reason is that impurities of manganese 2 plus replaces zinc Zn in the crystal grid. I didn't make that up. I looked it up. That's the reason why colorless willemite becomes blue. And the photo is a bit of a mess, but it's the only specimen I have. But you can see the structure of willemite here is quite visible. But it's blue. No drawing of this. Also, this one also, Wüstite belongs to the isometric system. It's very simple stuff. Iron monoxide actually, and it's logically this is widespread in all kinds of shapes. I was just the other day I was studying a brick that I got a few years ago from David Eiffel, which from some place in Cornwall, which is literally loaded with trees of these ladders of this wüstite. And well, if you isolate them well enough, then you can make nice pictures of them. And so tree-like structures and ladder-like structures are let's say, common for this mineral. Zinc aluminite forms tiny white hexagonal platelets, but they are so small, I told you that you can see individual crystals only under strong magnification. And at Genna and here in Letmathe, they are almost always covering needles of cassiterite, zincite, together with bluish saprolite and greenish ctenosite. And buildings like these were very, very widespread. In the 8 boxes that I still have, I think you can make a few hundred of these specimens if you get them clean. This looks like something in my Chinese food, but it's zincite. It was very abundant here, mostly as elongated crystals covered with another mineral, namely zinc aluminite. Here we go again, saprolite, ctenosite. These are, let's say, naked zinkites. And these also, it's a very delicate sample. I think if I blow too hard, then it falls apart. It's also zincite. And the last one, another one, is another crystal habit. You can see that here. This habit is different because it has some more spatial orientation. But it's also zincite. And that's it for today.
That's excellent, Henk, as usual.
Thanks. Wait, here I am.
Do we have any questions for Henk?
Well, Henk, there are a lot of tree-like forms in the Letmathe smelter.
So a lot of what forms?
Tree-like, forming trees.
Dendritic?
Oh, trees, yes.
Yeah, dendritic, correct. Sorry,
Dendritic,
that was the word
yes.
I was looking for.
Yes, trees.
But in other smelters, you don't see that much. Is it specific for Letmathe?
Yeah, that's yeah. So, for cassiterite like these, I have never seen before anywhere else. The same goes for these oxyplumbaromiites. I think it's quite typical for here. But there are, of course, a lot of minerals who form the dendritic crystals. So a lot, but these two are quite typical for this location, as far as I know. Yeah,
Oh, nice.
these. Well, I already had a few of these cassettoids, which Uli Wagner gave me a few years ago. And that was actually the reason why I wanted more. So then I went on and on and on. And then they gave me the book. And from that book, I went to Bernd, the other co-author, who is.
I'll ask him for the book because I met Ulrich at the BMS last year. So
yeah, I was there. Yeah. And Deuno is in his 80s, so he's selling all everything he has now. And he asked me to look around if there are some people who would like his. He has a lot of slag mineral collections from Germany and also from the Harz, Julius Hütte, etc. So I think I'm going back there one of these days and see what he has, what he still has left in his shed. But he has a very large collection. And the selection that I bought from him contains all the minerals in the book. And I photographed them in my own way, of course. But there are almost 400 of those. So it's a lot. Yeah. And from these, how many? Let's say 170 different species. I have quite a lot. Yeah, more than what I showed you today because it would take too long. But there's it's very, let's say, well, uncommon mineral, uncommon material.
Do we have any other questions?
I do.
Oh, go Kathy.
Hi, everybody. Henk, I entered a little bit late. I'm sorry, but your program was on the Genna zinc smelter. Are these all slag minerals?
Yes. Zinc smelter is always slags.
So now you kind of teach me why people collect slag. I've never considered this level of collecting. You have a great collection. Thank you.
Okay, if you want slags, I have thousands of slag minerals from the Greece, the Greek slags near Lavrio, from a lot of slags in Tuscany. I was there several times. From a lot of slags in the northern part of Germany, in the Harz Mountains. They're all slag localities which are, to slag collectors, are world famous. And they make the most beautiful crystals. No, but all very, very small.
Henk,
Yes.
Jim Lawson, do you know about the Slag Mineral Society?
No.
It was, of
It
course,
doesn't
when
ring
they
a bell.
started it.
How do you call that? The Slag Mineral Society.
Yes, it's no longer
South
active.
African.
It was Horst Wendisch.
Yeah. Okay. Yeah. Okay. I know that name. Yeah.
Yeah.
There's a series of publications that are just copies, about 4 or 5 pages long, on different localities.
All right.
I have about half of them. I'd be willing to share.
Are they digitized?
No, I'd have to scan them.
With the paper, you mean?
Yeah,
You
paper.
have them on paper or digital?
I have them on paper.
Okay.
I can scan them though.
Yeah, that would be very nice. Yeah, thanks. Because I know a lot of people who refuse to collect slag minerals because they think they're man-made. Well, they of course they grow because due to human interference, of course. And humans do things. They work in mines and they have leftovers. The leftovers gone, etc. So that's the reason why slag minerals for some people are not natural. The IMA has the same problem because they ignore slag minerals also. And the discussion now is going a little bit in the direction, or maybe we should accept them at last.
Chemistry is chemistry, you know.
Yeah,
Sorry?
again, exactly.
It's nature and
Chemistry is chemistry.
Yeah,
That's right.
So the slag is man-made, the minerals are not.
That's right.
Correct.
They've grown naturally on the slag.
You tell that to the IMA. You tell that to the IMA.
But that's
And
what
to a lot of folks I know who refuse to collect.
I'm not one of them.
flags. Sorry? No,
I'm
but
not one of them.
Andre
I agree.
Rommelt, you know Andre Rommelt. He is totally against the slags. No, well, okay. But you don't know what you're missing.
right.
Kathy.
So do you post anything on Mindat? And if so, where? Is there a slag category, or where do they fit?
You go to my website and you'll find hundreds of photos of slag minerals in all different parts of the world. And you
I
can
think
see,
maybe
you can see where on every photo it says where it comes from. So you can easily look up all the slag minerals. I have also some photos from Mindat, but yeah, as I have my own website, I don't do that too much. No. No.
Now I'm putting the link in the chat,
Sorry.
Kathy. So
Okay.
Okay.
there you go.
Yeah, thanks. Hey, I know that.
I recognize the website.
That's familiar.
Everything that I always show you is also on my website. So if you want to look something up or look something back, always do that.
I got it.
All right. I don't sell that.
No.
Nothing.
Yeah, last
then
week. Sorry, go on,
Can
Kathy.
I ask one other question? Then your photography, your micromineral photography. What's your best approach?
My best approach. Lots of patience. Well, yeah, well, you can tell a lot about that, but first of all, you have to have, let's say, reasonably good equipment. I never use a microscope for making photos. I always have directly from the camera to the with let's say ultra macro lenses and a stacking device, and the rest is trial and error. I do all the parameters, ISO, shutter speed, f, etc., lighting, and we play a lot with lighting, so that the light gets diffused as possible, as much diffused as possible, and then the computer has to work, because I only set the parameters as how I want them. But everything is a question of practicing. My photos from 5 years ago, I throw them all away because they're just not good enough anymore. Because you develop yourself, and at least that's what I hope. You try to get better, but it takes a lot of patience. Yeah, sure, of course, and a lot of practice. But
Thank you.
It starts with the equipment. Also on my website there is a full description of how I work. The making of the photos, a chapter on the website.
I was going to say, last week I was in South Australia for the Australasian Mineralogical Society's seminar, and got to go to a silver lead mine in South Australia, which has a big pile of slag on one side, and got to find at least a bit of gypsum in it. There's always something in the slag.
In Germany, these old Greeks, they tried to pull the silver out of out of the land to make these little coins they had, tetradrachms, they're called, and everything. So they had to divide the silver, lead, copper, etc. They do that by heating, and they had ovens on the beach, and everything that came out as slags out of these ovens, they threw into the sea. And in the course of years, these slag pieces have always remnants of the different elements, and they started reacting with the seawater. So now then you get lots of different minerals that you find almost anywhere, nowhere else, but just in these sea slags. So when we go to Greece, we have to dive them up. So we have to go into the sea to collect them. So we're in the water, like some, a bunch of walruses, I would say. And that's one way to get them. And then you take them home, because they are quite heavy, and then at home you start breaking them all. Very, very easy, very carefully, because if you just put a hammer on it, you break everything. So yeah, we have let's say special devices. It's a big word, but to make small pieces of these slags. Slags are about this big, and then you put and these cavities with these tiny crystals are just millimeters. So you have to be very careful. And a lot of work. And hey, it's a hobby. Work, no?
Any other questions for Henk before we finish up? No? All right. Thank you, everybody, again. And we'll see you in probably about 5 weeks or whatever.
Thank you, Henk. That was great.
Okay.
Yep.
Yeah, thanks, Hank.
Bye-bye.
Bye.
Pleasure as always. Ciao.
See y'all.